NASA is preparing to send something completely new to another world. Not a rover, not a normal lander, but a flying machine. Its name is Dragonfly. A first-of-its-kind rotorcraft designed to explore Titan, the largest moon of Saturn. Titan is one of the strangest places in the solar system. It has a thick atmosphere, it has clouds, it has dunes, it has lakes and seas on its surface. But this is not Earth. The lakes are not made of water. The sky is not blue. And the world is so cold that chemistry behaves in ways almost impossible to imagine. Dragonfly will not stay in one place. It will fly. It will land, take samples, study the surface, then take off again and travel to another location. For the first time, humanity is planning an airborne science mission on another world. And its target is one of the most mysterious moons we have ever discovered.
Titan is not just another moon. It is bigger than the planet Mercury. It has a dense, nitrogen-rich atmosphere, and from a distance, it looks like a small orange world wrapped in haze. That haze hides the surface from normal view. For years, Titan was one of the great mysteries of the outer solar system. But when spacecraft began studying it more closely, scientists discovered something incredible. Titan has landscapes. It has vast dune fields. It has river-like channels. It has lakes and seas near its poles. But instead of liquid water, many of these lakes are made of methane and ethane, chemicals that exist as gases on Earth, but can become liquid in Titan's extreme cold. That makes Titan feel strangely familiar and completely alien at the same time. It is like Earth in shape and process, but not in temperature, not in chemistry, and not in the kind of life we know. That is why NASA wants to go there. Titan may help scientists understand how complex chemistry develops before life begins.
Dragonfly is a rotorcraft. In simple words, it is a flying robot. But it is not just a drone like the ones we use on Earth. Dragonfly is a science spacecraft designed to survive on Titan, fly through its thick atmosphere, land on its surface, collect samples, and analyze them with scientific instruments inside the vehicle. The mission is planned to launch no earlier than July 2028. If everything goes according to plan, Dragonfly will arrive at Titan in late 2034. That means this mission is not just about one landing, it is about exploration over time. Dragonfly is designed for a planned mission of about 3.3 years on Titan. During that time, it will travel to different locations, studying places that may reveal how Titan works, what its surface is made of, and whether its environment could be connected to the chemistry of life. This is what makes Dragonfly so different. A rover can only drive. A lander can only study one place. But Dragonfly can fly from one world-changing question to the next.
On Earth, flying takes energy. A drone has to fight gravity and push against the air. But Titan is different. Titan has a thick atmosphere and lower gravity than Earth. That combination makes flight much more practical than it would be on many other worlds. For Dragonfly, Titan is almost perfect for flying. The atmosphere is dense enough for rotors to work effectively. The gravity is weak enough that a rotorcraft can lift itself more easily than it could on Earth. This is one reason NASA chose this design. Instead of sending a rover that might only explore a small area, Dragonfly can cover miles of terrain. It is expected to make one flight every 1 to 2 Titan days. A Titan day, called a sol, lasts about 16 Earth days. So Dragonfly's journey will be slow, careful, and deliberate. It will fly, land, study, wait, then fly again. Each flight could take it to a new piece of Titan's story.
Dragonfly will not just look at Titan, it will touch it. At each landing site, the rotorcraft will collect samples of surface material and analyze them inside the spacecraft. This is one of the most important parts of the mission. Titan's surface may contain organic molecules, carbon-based chemicals that are important for understanding prebiotic chemistry. Prebiotic chemistry means the chemical steps that may happen before life appears. Dragonfly will explore a variety of geologic locations, including dune fields and Selk Crater. These places may contain materials that were shaped by impact, atmosphere, and surface processes over long periods of time. By studying different locations, Dragonfly can build a more complete picture of Titan. Not just what one spot is like, but how the whole environment works. What chemicals are there? How far has complex chemistry progressed? Could Titan contain ingredients that help scientists understand the path toward life? Dragonfly is not going to Titan to find cities, animals, or anything like science fiction. It is going there to search for chemistry. The kind of chemistry that may tell us how life could begin.
When scientists talk about habitability, they do not always mean a place where humans could live. Titan is not suitable for humans without advanced protection. It is extremely cold, its atmosphere is not breathable, and its surface chemistry is very different from Earth's. But habitability can mean something deeper. It can mean an environment where important chemical processes are possible. It can mean a place where organic molecules form, change, and interact. It can mean a world that helps us understand the steps between simple chemistry and the possibility of life. Dragonfly will investigate Titan's habitability by studying its environment, its chemistry, and its surface materials. It will search for compounds of astrobiological interest. It will look for chemical indicators that could be connected to water-based or even hydrocarbon-based life. That does not mean Dragonfly will definitely find life, but it could find clues. And those clues could change how we think about living worlds. Titan is not Earth, but that may be exactly why it matters. It gives scientists a chance to study a different kind of world, a world where chemistry may follow a different path.
Dragonfly is part of NASA's New Frontiers program, a program designed to answer some of the most important science questions in our solar system. The mission is managed by the Johns Hopkins Applied Physics Laboratory, with partners from NASA centers, universities, and space agencies around the world. But beyond all the engineering, all the instruments, and all the mission planning, Dragonfly represents something bigger. It is a new way to explore. For most of space history, we have looked at other worlds from orbit, landed in one place, or driven slowly across the surface. Dragonfly will do something different. It will fly through the sky of another world. It will move from place to place, choosing new landscapes, new samples, and new clues. A machine built on Earth will rise into the orange haze of Titan and search for answers on a moon almost 1 billion miles away. Titan may be cold, dark, and alien, but it may also hold secrets about chemistry, habitability, and the origins of life. And one day, when Dragonfly touches down on that distant surface, humanity will begin a new chapter of exploration. Not just landing on other worlds, but flying through them.